Welcome back to the unit step. Today we're going to solve initial value problems. So let's just get started with a quick review. On A here, I'm going to use formula 17, which you can see is appropriate, and A is going to be 1, and little f of t is L inverse of the fraction 5 over s times s plus 1. And I did partial fractions on that, so I'm going to write down the partial fraction version. 5 over s, I know those 5s look like s's, minus 5 over s plus 1. Okay, and that's 5 minus 5e to the negative t. So that's my f of t. And so by formula 17, L inverse is equal to, I want f of t minus 1. So 5 minus 5 e to the negative parenthesis t minus 1, and all of that, you need parentheses around all of that, gets multiplied by u of t minus 1. All right, and we're going to use that in the next problem. So that's going to come up, and we'll just refer to that. Okay, so first step is to rewrite f of t using the unit step. So I'm going to use that formula from the 7.5 lecture notes. I want f1, which is 0, plus f2 minus f1, 5 minus 0, u of t minus 1. So that's just 5u of t minus 1. So that's f of t. All right, so the differential equation I'm solving is y prime plus y equals 5u of t minus 1. So step 1, take L of both sides. L of y prime plus y is L of 5u of t minus 1. Okay? So L of y prime, that's S big Y minus y of 0, but y of 0 is 0. So S big Y plus big Y, and that's equal to, we could use formula 18. It would probably be easier to use formula 14 on this one because 5 is a constant. So this is just 5 e to the negative s over s. Okay, let's isolate big Y. So big Y times s plus 1 is equal to, I'm going to pull that e to the negative s out because I'll be using formula 17 in a minute. That's an s, e to the negative s, and then 5 over s. And then divide both sides by s plus 1. So big Y is e to the negative s times 5 over s times s plus 1. All right, now take L inverse of both sides. On the left, we get little y, and on the right, we get L inverse of e to the negative s times 5 over s times s plus 1. A lot of parentheses there. Okay, but we just did that. That's the first problem we did. So little y of t is, so our answer from before, 5 minus 5 e to the negative t minus 1, and all of that was multiplied by u of t minus 1. And there it is. Okay, so why don't you give it a try? Pause the video and solve this problem. It's very similar to the one we just did. It'll take longer if you do that, but you'll learn more than if you just watch me do it. Same with the next problem. All right, here we go. We've got an RC circuit, and I'm using this formula here. I'm going to plug in the values given. Big R is 1 ohm, so I've got Q prime plus 1 over C. C is a half. F is for farads, I think farads, so 2Q equals E of t, and E of t I'm told is 5u of t minus 3. So there's my dE. I'm going to take L of both sides. L of q prime plus 2q is equal to L of 5u of t minus 3. So on the left, I get S big Q minus Q of 0. Q of 0 is 0. So plus 2 big Q equals, I'm going to use formula 14 just like we did before, 5e to the negative 3s over s. So factor out a big Q, s plus 2 comes over here, and that's e to the negative 3s, I'm going to take that out, times 5 over s. Okay, almost there for isolating big Q. Big Q is equal to e to the negative 3s times 5 over s times s plus 2. Okay, so now we're going to take L inverse of both sides. When we take L inverse of big Q, we get back to little q. So little q of t is L inverse of e to the negative 3s. And the partial fraction decomposition for this guy is right here, up above. So I'm going to write that down, 5/2 s minus 5/2 over s plus 2. That's a super easy partial fraction decomp to do, and you could do it on your own, but if you're confident that you could do that, I'm fine with you saving time by just going to Symbolab or some other technology and having it do that for you. Okay, so now we're up to number 17 with a equal to 3 and f of t equal to L inverse of 5/2 over s minus 5/2 over s plus 2. Okay, that's 5/2 minus 5/2 e to the negative 2t. That's my f. So by formula 17, little q of t is, I want f of t minus a, and a is 3. So 5/2 minus 5/2 e to the negative 2 t minus 3 all times u of t minus 3. And that's our final answer. Okay, last one. I really hope you did it on your own. It's pretty interesting. All right, so first step, write g of t using unit step. G of t is, our f1 is 3 sine t, and then we want plus f2, which is 0, minus f1, which is 3 sine t, times u of t minus 2 pi. All right, and so I'll clean that up in a second when I write down the differential equation. Our differential equation is I double prime plus 4i equals g of t, and g of t is 3 sine t minus 3 sine t times u of t minus 2 pi. All right, now we're going to take L of both sides. L of I double prime plus 4i is equal to, now L is linear, and so since I'm going to need formula 18 on this guy, and I'm not going to need it on this guy, what I'm going to do is separate it out and take L of 3 sine t separately, and then minus L of the rest. You would do the same thing if you were integrating two functions and one needed a u sub and one didn't. You'd write it as two integrals. 3 sine t times u of t minus 2 pi. Okay, so here we go. L of I double prime is s squared big I minus s I of 0. So I of 0 is 1 and I prime of 0 is 3. So this would be minus s minus 3 and then plus 4 big I, and that's equal to L of 3 sine t, that's easy, that's 3 over s squared plus 1. Hopefully you have your Laplace transform table handy. And then minus L of this guy, and here's where we need number 18. So we're going to use 18 with a equal to 2 pi, and g of t is 3 sine t. So we're going to need g of t plus 2 pi, and that's 3 sine of t plus 2 pi. Now to use formula 18, I'm going to have to take L of that, and so I'm going to expand this using the sum and difference formula for sine and clean it up, because I can't do anything with the way it is. That's 3 sine t cos 2 pi plus cos t sine 2 pi. Okay, sine of 2 pi is 0, cos 2 pi is 1, so 3 sine t. So back over here, we get e to the negative 2 pi s times L of 3 sine t. All right, and let's clean up a little bit on the left. We've got s squared plus 4 all times big I, and let's take the s and the 3 right here and move those to the other side. So s plus 3, and then I still have this guy, 3 over s squared plus 1. And now I have minus e to the negative 2 pi s times L of 3 sine t. And L of 3 sine t is 3 over s squared plus 1. Okay, now divide both sides by s squared plus 4 to isolate big I. Big I is s over s squared plus 4 plus 3 over s squared plus 4. Those aren't going to give us any problems. Those are sines and cosines. Plus 3 over s squared plus 1 times s squared plus 4 minus e to the negative 2 pi s times 3 over s squared plus 1 times s squared plus 4. All right, I've got the partial fraction decomp for 3 over s squared plus 1 s squared plus 4 up here at the top, and we're going to use that in two places. So big I is equal to s over s squared plus 4 plus 3 over s squared plus 4 plus, now use the partial fraction decomposition, 1 over s squared plus 1 minus 1 over s squared plus 4. All right, minus e to the negative 2 pi s. And again, partial fraction decomposition on this guy is it's 1 over s squared plus 1 minus 1 over s squared plus 4. All right, so now I'm ready to take the inverse Laplace transform of both sides. So I'm back to little I on this side, and I want L inverse of, now I'm going to do a little bit of cleanup. I've got s over s squared plus 4, and then I can combine like terms because I've got 3 over s squared plus 4 minus 1 over s squared plus 4 gives me plus 2 over s squared plus 4, and then I have the 1 over s squared plus 1. So I want L inverse of that, and I'm going to do that separately from L inverse of this next piece, because L inverse of the next piece requires formula 17. So here I've got e to the negative 2 pi s. We're going to use up the whole page here. And then 1 over s squared plus 1 minus 1 over s squared plus 4. Okay, so now formula 17. Let's work on this guy before we write down the next line. We've got a equal to 2 pi, and f of t is L inverse of that fraction, well, both those fractions, 1 over s squared plus 1 minus 1 over s squared plus 4. So f of t is equal to sine t, and then this next piece is minus 1/2 sine of 2t. All right, so now I'm ready to go back to this side. I of t is, let's start taking L inverse of these pieces. This first guy, this first fraction is cos 2t. The second fraction is sine 2t. And the third fraction gives us sine t. Then we get minus, got f of t over here. Well, I just erased it. F of t, that was 1/2. I want to take f of t minus 2 pi. So sine of t minus 2 pi minus 1/2 sine of 2 t minus 2 pi. All of that gets multiplied by u of t minus 2 pi. All right, now let's just do our final cleanup here. We've got I of t is equal to cos 2t plus sine 2t plus sine t minus, big old set of parentheses. Let's use the periodic property of sine. Sine of t plus or minus any multiple of 2 pi is just sine of t. So this is sine t minus 1/2. If I distribute the 2, I get sine of 2t minus 4 pi, which is just sine of 2t. And those two pieces get multiplied by u of t minus 2 pi. Whew, that's it. Now, it looks a little bit scary, but remember, this is just a piecewise defined function. This is just, if you graph this, it would just be sines and cosines, and then before you get to 2 pi, this second half would be 0, and once you get to 2 pi, this second half would kick in, and you'd be subtracting sine t and then adding 1/2 sine of 2t. Okay, and that's our final answer. Hopefully that's what you got when you did it on your own. All right, and that is the end of this section.